All right, guys, so today's lesson is on 4.6. So if you go into your packet and find the paper that says 4.6 at the top, as I'm going through this PowerPoint, you'll find spaces to put all the answers. Okay, so here we go. So more than anything, I need you today to start to learn some special vocabulary. Okay, so the language of sequences. All right, let's see if I can talk about this. Sequences have their own notation and vocabulary. We've already sort of talked about terms and term numbers. So the term number is like the position in the list. Like this is position 1, position 2, position 3, position 4. But the terms themselves are the actual numbers that are in the list. Okay, now this is also asking, first question, is this arithmetic, geometric, or neither? That's asking you to figure out what the pattern is. Are you adding? Are you multiplying? Or is it something completely different? So on this one, if you look real close, maybe you have to use a calculator, don't know, but the pattern here is adding 4, right? You are adding 4, which makes this particular one arithmetic. Okay, scooting it up, same sequence. So now it's saying, and again, this is all just about vocabulary, okay? It's asking what is the first, let me undo that, give me a sec. Right there. It's asking what is the first term. It's asking, in other words, what's the first number in the list? So that would be a -9. Okay, next question, same sequence. What is the sequence generator? In other words, and we've already actually answered this question, what is the pattern as you're going from one term to the next? So this one would be a +4. That's what keeps the sequence going. Okay, still the same sequence. It says record the sequence in a table. Okay. All right, and again, you're on your paper and you have a table. So the term number, which is the left-hand column, is n, and then this is going to go where n is 1, and this goes where n is 2, this goes where n is 3, etc. Okay, now in question E, would this graph be continuous or discrete? This one would be discrete, only because it doesn't tell you any information about any other numbers except for term number 1 and term number 2 and term number 3, right? There is no term 1.5 or no term 6.5, right? So that would be your Y, all right? How would the common difference be related to the graph? So if you graphed this, right, if you actually went off into the margin and made a teeny tiny little graph, you would see this number, that +4, show up as the slope. Okay, and I'll let you answer why it makes sense. Okay, so in your packet, make sure that you answer that question of why you think that makes sense. Okay, now as far as modeling the sequence, this is just writing the equation. And what we know so far is that the slope is 4, right? We just talked about that. What we're missing is B. Okay, now I'm going to teach you a really quick, simple, little easy way to find B if you have term 1, term 2, term 3. All you need is term 0. Right? If you can calculate this pattern backwards, one step, right? So if you can tell me what number should be right here, which in this case is -13, now you've got B, -13. So your equation that you're going to write, there's probably a blank on your paper, is 4n plus, oh, actually not plus, sorry, minus 13. This is the same thing as mx plus b. That's the slope, and that is your y-intercept, or for us, the 0 term. All right, let's keep going. Okay, so now we're going to start talking about this thing where the initial value, right, or the 0 term is going to be part of your sequence. T of 1 is the first term. Okay, so now it's asking you, and again, this follows the same way that your worksheet does. Here's a whole other pattern, okay, where you've got the first term, the second term, the third term, the fourth term, okay, and again, I'm going to just ask you some questions about it. Excuse me. All right, so this pattern, if I'm looking real close, is adding 3. Add 3, add 3, add 3. So if it's asking what the common difference is down here, that's adding 3. The first term, you can see that right there, that's -4. And the 0 term would be if I kept going backwards 1 step, literally just 1 step. So the 0 term here is -7. Okay, so I'm hoping that makes sense. If not, I can answer your questions when I see you again. So now it's asking you to write an equation for T of n. So T of n is going to equal the pattern generator or the sequence generator times n, and then all I need is the 0 term, which in this case is -7. Okay, now it says verify your equation works for each of the first 4 terms. So what is T of 1? Well, that's 3 times 1 minus 7. That's 3 minus 7, which is -4. What is T of 2? That's 3 times 2 minus 7, or 6 minus 7, which is -1. T of 3 is 3 times 3 minus 7, which is 9 minus 7, which equals 2. And the fourth term is 3 times 3, nope, not times 3, times 4, there we go, minus 7, or 12 minus 7, which equals 5. So you can see that these 4 terms are the first 4 terms. Okay, now this is the question that's probably the most important one. It's asking somewhere in the list, right? So this list keeps going on and on and on and on, right? There's lots and lots and lots of numbers. The question is, is 42 part of the list? Okay, so I'm going to take that equation that we just came up with, which was 3n minus 7, and I'm going to set it equal to 42. And I'm going to see if I can find an n value that's a whole number, right? Not a fraction, not a decimal, but a whole number. So if I move this to the other side, I get 3n equals 49. And if I divide by 3, it doesn't go in evenly. I get a fraction. So the answer to this question is no. And this is your justification. N would be a fraction. All right, so let's take a look. So for this function, is it possible for f of x to equal? Now this is different. Okay, let me go back just a sec. This is asking very specifically about T of n. T of n is talking about term numbers, but this problem is asking about functions. Okay, functions don't have to have whole numbers. You are allowed to have fractions. So for this one, the answer is yes. That should be a pen. Let's try that again. Yes. There we go. Functions can have fractions. That's your answer here that you'll need to have on your worksheet. Functions can definitely have fractions. Okay. Okay, the rest of these examples I will probably pick up when I get back. But for now, this is your entire lesson. Good luck. I'll see you soon.